This is the video solution to practice problem A that accompanies sample exercise 1.1 in the textbook. The problem that we're going to solve appears at the top of page 11. Practice problem A asks us to express the freezing point of water, or 0 degrees Celsius, and the boiling point of water, 100 degrees Celsius, and the range that's spanned by these two temperatures using the Kelvin scale. So in our solution, we will carry out two temperature conversions, one for each Celsius temperature converted to Kelvin, and then we will find the range of those temperatures in Kelvin. The easiest way to do this will be to look at the exam information sheet for our temperature equations. The exam information sheet accompanies all of your quizzes, written quizzes, and exams in this course. The top part of the exam information sheet starts with useful constants and conversion factors. And if you look at the fourth equation down in the conversion factor category, you see an equation that relates Kelvin temperatures to Celsius temperatures. This is the equation that we will have to use to solve this problem. So we'll start with the freezing point of water, 0 degrees Celsius, and convert 0 degrees Celsius to Kelvin. The equation says that temperature in kelvins is equal to temperature in degrees Celsius plus 273.15. We know our temperature in degrees Celsius, so we'll simply plug in 0 degrees Celsius for Tc and solve for Tk. The significant figures have been correctly underlined here. In 0 degrees Celsius, we know this value to the ones place. And since we're adding, we'll keep track of where that decimal point is and know that when we round, our Kelvin temperature will have to be rounded to the ones place as well. When we look at the boiling point of water, the 100 degrees Celsius, and convert that to Kelvin, the same equation applies. It's the same process. And we'll simply plug in 100 degrees Celsius in our equation and solve for a Kelvin temperature of 373.15. Again, we're going to assume that we know 100 degrees Celsius to the ones place. That's an assumption. And if we make that assumption, then our Kelvin temperature will also be rounded to the ones place, and it will round to 373 Kelvin. So these two values, 273 and 373 Kelvin, make up the first part of the solution to the equation. We've converted the Celsius temperatures to Kelvin. Next, we need to think about the range that's spanned by these two temperatures. In other words, what is the difference between 373 Kelvin and 273 Kelvin? And solving that will simply be a matter of subtracting. So 373 Kelvin minus 273 Kelvin is 100 Kelvin. And since we assumed that we knew all of our initial temperatures to the ones place, we can also assume that we know our temperature range to the ones place as well. So writing 100 Kelvin with the uncertainty in the ones place means that we have to either put in a decimal point or use scientific notation to represent our final value. So it would be either 100 decimal point Kelvin or 1.00 times 10 to the second Kelvin. And before we leave the problem, we should check to make sure that it's conceptually right. So if we think about the difference between the Kelvin and the Celsius scales, Kelvin is simply higher than Celsius by a value of 273.15. which means that the range of our Celsius temperatures, the difference between the values, should be the same in the Kelvin scale. The size of a degree Celsius is the same as a Kelvin degree.